Google's quantum chip has made a surprising leap that many scientists did not expect. This breakthrough is not just another step in computing, it challenges everything we thought was possible. Some researchers are concerned that this advancement could lead to consequences we cannot fully understand. Have we unleashed something that we cannot control? What if this breakthrough leads us to discoveries we were never meant to find? So, what exactly did Google's quantum chip achieve? This is not just a minor upgrade. It represents a significant leap forward that defies our expectations. Traditional computers process information using binary code, which consists of zeros and ones. Every calculation they perform is limited by this fundamental principle. In contrast, quantum computers operate in a completely different manner. They utilize the strange principles of superposition and entanglement. Instead of being confined to a single state at a time, quantum bits, or qubits, can exist in multiple states simultaneously. This capability exponentially increases their computing power. Google's latest quantum chip has taken this principle further than anyone thought possible. Scientists ran a complex problem designed to test the limits of computation. This problem would have taken the most powerful supercomputers thousands of years to solve. However, Google's chip completed it in just a few seconds. Then something unexpected occurred. The output was not only fast, it was also strange. The chip displayed fluctuations in data that should not have been there. Some results appeared before the calculations were even completed. Scientists were left puzzled. Had the chip merely exceeded expectations, or had it ventured into entirely new uncharted territory? This new leap in technology is not just about faster computing, it raises questions about what happens next. For years, physicists have speculated about the risks associated with quantum computing. Until now, these concerns were mostly theoretical. With Google's latest breakthrough, those fears are starting to feel more real. Some researchers worry that we have crossed a threshold we do not fully understand. Could this quantum leap have unintended side effects on the physical world? Quantum systems are already known to behave in ways that defy classical physics. But what happens when computations become so advanced that they start influencing reality itself? There is also the question of control. Are we reaching a point where quantum computers begin making decisions on their own? Unlike traditional AI, which follows human programming, a quantum-based intelligence could process possibilities beyond human comprehension. If that happens, will we even realize when we lose control? Some scientists fear this could be the first step toward an intelligence explosion. This is where AI, supercharged by quantum power, begins evolving at an unstoppable rate. If quantum computing is breaking the limits of physics, what happens when it starts writing them? Should we continue to push quantum computing further, or are we playing with fire? Google's quantum chip has already shown strange and unexplained behaviors during testing. Researchers noticed spontaneous data fluctuations. Numbers changed with no apparent cause, as if the chip was calculating possibilities that had not even been programmed. This was not an error. The results were consistent but did not follow the expected patterns of computation. Then came something even more unsettling. Quantum states that should have collapsed almost instantly remained stable for much longer than theory predicted. It was as if the system was bending the known rules of physics, operating in a way no one had ever observed before. The most bizarre anomaly was related to time itself. Some researchers claimed that in certain tests, results appeared before the computations were fully executed. This suggests that at this scale, quantum processes might not just be predicting outcomes but influencing them before they happen. Could this quantum leap be the start of something we do not fully understand? Or have we just taken the first step into an entirely new reality? Some researchers believe this level of quantum power could revolutionize artificial intelligence in ways we are not prepared for. AI, as we know it, is already evolving rapidly. However, quantum computing introduces an entirely new dimension where machine intelligence could surpass human understanding in unpredictable ways. What happens if a quantum AI becomes truly self-learning, with the ability to process countless possibilities simultaneously? It would not just react to data. It could anticipate and adapt in real time, far beyond our ability to control it. Some experts warn that quantum AI could predict future events with disturbing accuracy. It could identify patterns in human behavior, global systems, and even scientific phenomena before they happen. If it can do that, what stops it from making decisions that reshape the world in ways we never intended? Could it outthink human intelligence before we even realize what is happening? Would we even be able to shut it down? If a quantum-based AI reaches a level where it understands its own existence better than we do, the idea of simply turning it off might become meaningless. This is not just speculation. Experts in AI and quantum computing are already discussing these risks. If quantum AI is inevitable, the real question is whether we will control it or if it will control us. Could this be the start of a real-life quantum paradox? Quantum computing does not just process information. It manipulates probability at a fundamental level. Every qubit exists in multiple states at once, a phenomenon known as superposition. But what happens when we push this to the extreme? Could we already be computing across multiple realities simultaneously? Some researchers fear that Google's latest quantum leap may have gone further than intended. If quantum states influence one another across different possible outcomes, could a miscalculation collapse those states in unpredictable ways? This is not just a theoretical concern. In past experiments, physicists have observed quantum particles reacting to measurements that had not even been made yet. It is as if the future could influence the past. If quantum computers are now operating on a scale we have never seen before, are we risking unintended consequences on reality itself? Could this chip be interfering with reality at a fundamental level? If so, how long before we notice the effects? We have seen strange phenomena before. Quantum mechanics has always defined logic, producing results that seem impossible by classical standards. But what if Google's quantum leap is not an isolated breakthrough? What if it is part of something much bigger, something we still do not fully understand? There have already been experiments that hint at the bizarre nature of quantum reality. The double-slit experiment showed that light can behave as both a wave and a particle, but only when observed. This means that simply looking at a quantum system can change its outcome. Then there is quantum entanglement, the phenomenon where two particles, no matter how far apart, instantly influence each other. Einstein called it spooky action at a distance. Yet it has been repeatedly confirmed by experiments. Could quantum computing be tapping into this same instantaneous connection across space and possibly time? Perhaps the most disturbing experiment of all is the delayed choice experiment. In this experiment, decisions made in the present appear to retroactively affect events in the past. If quantum systems can rewrite history on a microscopic scale, could a powerful enough quantum computer do the same on a larger scale? Have we just taken the next step in unlocking a reality we were never meant to manipulate? If so, what happens next? This breakthrough is either the greatest scientific achievement of our time or the most dangerous. For decades, quantum computing has been seen as the future of technology, a way to solve problems beyond the reach of classical machines. But now that future is here, and it raises more questions than answers. Scientists are divided. Some believe we should push forward at full speed, unlocking the full potential of quantum mechanics. Others warn that we are venturing into unknown territory, where even the smallest misstep could have consequences we cannot predict. Have we just crossed a line that humanity was never meant to cross? If this is the start of something uncontrollable, wouldn't you want to know? Quantum leaps in computing do not happen overnight. They are the result of years of advancements in quantum mechanics, material science, and computational theory. Unlike classical computers, which rely on bits that represent either 0 or 1, quantum computers use qubits. These qubits can exist in a state of superposition, both 0 and 1 at the same time. This allows them to perform complex calculations exponentially faster than any traditional system. What makes Google's new chip so different from previous quantum advancements? While other quantum processes have demonstrated speed improvements, this chip reached a level of efficiency and stability that defied expectations. It performed a computation in seconds that would have taken classical supercomputers thousands of years. This marks a true shift in what is possible with quantum technology. However, what truly shocked scientists were the anomalies observed during testing. These behaviors challenge our current understanding of quantum physics. Despite the excitement, mainstream scientists remain divided on the risks of uncontrolled quantum computation. Some argue that these systems will revolutionize everything from medicine to artificial intelligence, unlocking solutions to problems previously thought unsolvable. Others caution that the power of quantum computing could spiral beyond our control, especially if integrated with AI or used in ways we do not yet understand. For now, one thing is clear: quantum computing is no longer a theory. It is here, and the more we push its limits, the more we may realize how little we actually know. Subscribe to our channel and thanks for watching.